Well, in this sequence, we will explore sequences and iterations. Well, now we have discovered how to write functions which perform side effects. And since we have function side effects, it becomes interesting to put them one after the other to create sequences, or maybe to execute them many, many times over by writing loops. Let's start with the sequences of expressions. Imagine you want to print several values one after the other. If I want to print 1, 2, 3, how could we write this with the syntax and the constructs we know up to now? Well, a possibility is this one. We can use a let construct to say, well, print int 1, and then drop the result, then print int 2, and then drop the result, and then the final expression is print int 3. And of course I get 1, 2, 3 on the standard output as I wanted. But this is kind of cumbersome to write, very verbose. More concisely, OCaml allows you to write something like this. Several expressions, one after the other, separated just by a single semicolon. So you have print int 1 here, then the semicolon, then print int 2, then the semicolon, then print int 3, the semicolon. It does exactly the same as this expression here. And indeed, the result is always 1, 2, 3. An expression sequence is a list of expressions, like here in E1 to En, separated by semicolons. The evaluation of an expression sequence actually performs evaluation of each of the EI in turn, from the first to the last one. All the intermediate results are dropped, and we get as a final result the result of the last expression in the sequence. It is expected that all the intermediate expressions are of type unit, since we are dropping their values. Otherwise, your OCaml program compiler prints a warning for you. A word of caution when you're starting using the semicolon, because it is tempting to start writing pieces of code like this one. I mean, if condition, then print a string, then semicolon, then print some other strings, and something like this. The indentation let you think that actually these two print statements will be executed only on the then branch, but as soon as you hit enter, you will see that unfortunately there is this dot here that comes from this print statement here, which means that actually the semicolon here is binding less than the other constructs. So if you want to make explicit the order in which the sequence should be parsed, use parentheses around the sequence, or the more verbose, begin and behaves exactly like the parentheses. So what we really wanted to write before was something like this: if condition then begin and this sequence of statements here. And in this case, you see there is no more spare dot polluting your output here. Well, now let's move to iterations. What if we want to print all integers from 1 to 10, for example? Of course, we could print 1, then print 2, then etc. up to 10. It's better to have a programmatic way of doing this. And at this point in the course, I'm sure that you are pretty able to come up with a solution like this one. You can define a recursive function for each that has two parameters: a start value of the index, the end value of the index, and then the function f, which is passed the value of the index at each step. I mean, we'll not really comment to this code in particular here. The only point is that it really does what you want. If I do for each from 1 to 10 and pass the printing function as a parameter, I get exactly the integer from 1 to 10 printed on standard output. But you see, this is kind of cumbersome to read. We would really like to be able to write a sort of a for loop as in other languages. Well, the good news is you can do it. There is syntax for doing this. And actually you can do exactly the same by writing a more concise code like this one. You see, it's the typical for loop where you can have a variable for the loop, initialize it to 1, goes up to 10, and then you have the body evaluated for each of the values. The result is again the same. The general structure is for, then identifier bound to an initial value, to a final value, do the expression, the body of the loop, and the final keyword done. The loop identifier ID will take all integer values from E1 to E2 in turn, but big difference with other programming languages, you cannot change the content of this identifier. You can hide it inside the body, but you cannot modify it. The loop of the body is evaluated for each of the values of ID and does exactly what you want. Now, as for types, the type of the loop, of the for loop as a whole, is of unit type, as you have seen here. I have no value returned, only the side effects. And also the type of the loop body is expected to be unit. Otherwise, again here, the OCaml compiler will print a warning. As always, the warning means you can force the compiler to execute the program anyway, but you have been warned. There is an alternative form for the for loop. You can go also backwards. So when you do for e equal 10 down to 1, what happens is that you are printing the integer in the other way around. And of course, now it is behaved exactly like the other form of the loop, but now we are going from the higher value to the smaller one. And finally, we can also write while loops. The typical form is something like this. So we have while the condition do, the body of the loop done. So what happens is the condition E1 is evaluated. If it is true, then the loop body E2 is evaluated and the loop repeated again. If the condition is false, then the loop stops. The type of the while loop again is unit, and again here also the loop body is expected to be of type unit, otherwise you get a warning. Well, finally, let me remark that in some cases you may really want to use in the body of a loop an expression that has not a unit type. Well, there is a predefined function ignore, which is of type alpha arrow unit that you can use to wrap this value and transform them in something of value unit and avoid the warning. But at this point, your intention of ignoring this particular content has been made explicit. To sum up, we have seen we can create sequences of expressions. We can write for loop going up or going down. We can write while loops. And in all these situations, the body of the loops, intermediate expressions should all be of type unit, or otherwise you should declare your intention by using the ignore function.